Article 330.10 of the National Electrical Code addresses use is not permitted for metal-clad cable. It's important to understand these limitations to ensure code-compliant and safe installations. When evaluating the use of metal-clad cable for powering 1000-watt metal halide fixtures, consider several factors. Firstly, the ampacity of the 12 American wire gauge conductors within the metal-clad cable must be sufficient to handle the load of the fixtures. Article 310.15 and associated tables dictate ampacity based on conductor type, insulation rating, and ambient temperature. Check Table 310.15b16 for allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius. Secondly, the voltage drop should be within acceptable limits. Excessive voltage drop can cause the metal halide fixtures to operate inefficiently or fail prematurely. Calculations must consider the length of the metal-clad cable run and the current draw of the fixtures. Thirdly, the metal-clad cable must be properly supported and secured. Article 330.30 outlines the requirements for supporting and securing metal-clad cable. Support should be placed at intervals not exceeding 6 feet, and the cable must be securely fastened in place. Fourthly, consider the environment where the metal-clad cable is installed. Article 300.6 addresses protection against corrosion and deterioration. If the storage building has a corrosive environment, metal-clad cable with a suitable jacket or coating should be selected. Fifthly, the termination of the metal-clad cable at the junction box and the fixtures must be done correctly. Use appropriate connectors listed for metal-clad cable. Ensure that the connectors are properly tightened to maintain a secure electrical connection and prevent moisture from entering the cable. Sixthly, the grounding requirements must be met. Article 250 provides comprehensive requirements for grounding and bonding. The metal-clad cable must have an equipment grounding conductor that is properly connected to the metal enclosures of the junction box and the fixtures. Seventhly, the overcurrent protection for the circuit must be appropriate. The circuit breaker or fuses protecting the metal-clad cable must be sized according to the ampacity of the conductors. Article 240 addresses overcurrent protection. Eighthly, the existing junction box must be suitable for the intended use. The junction box must be large enough to accommodate the conductors and connections without overcrowding. It must also be rated for the environmental conditions of the storage building. Ninthly, the installation must comply with all other applicable requirements of the National Electrical Code. This includes requirements for working space around electrical equipment, identification of conductors, and protection of conductors from physical damage. Tenthly, the specific requirements for metal halide lighting fixtures must be followed. Article 410 addresses lighting fixtures. Ensure that the fixtures are properly installed, grounded, and ventilated. The ballast for the metal halide fixtures must be suitable for the voltage and frequency of the electrical system. To elaborate further on ampacity, you need to calculate the total current draw of the four 1000-watt metal halide fixtures. Assuming a voltage of 120 volts, each fixture will draw approximately 8.33 amps. Therefore, the total current draw for the four fixtures will be approximately 33.32 amps. 12 American wire gauge conductors in the metal-clad cable must have an ampacity of at least 33.32 amps. Referring to Table 310.15b16, 12 American wire gauge copper conductors with type THHN insulation have an ampacity of 30 amps at 75 degrees Celsius. If the ambient temperature is higher than 30 degrees Celsius, the ampacity must be derated according to Table 310.15b2. If the metal-clad cable is installed in a raceway or cable tray with other conductors, the ampacity must be adjusted according to Table 310.15 cone. If the calculated ampacity is less than 33.32 amps, the 12 American wire gauge metal-clad cable is not suitable for the installation. A larger size conductor or multiple circuits may be required. When considering voltage drop, the National Electrical Code recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current resistance for the conductor material, I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor in circular mils. For 12 American wire gauge copper conductors, the circular mils is 6,530. The direct current resistance for copper is approximately 12.9 ohms per circular millifoot. If the metal-clad cable run is 100 feet and the current is 33.32 amps, the voltage drop would be approximately 13.7 volts. This represents a voltage drop of approximately 11.4% at 120 volts, which exceeds the recommended limit. To reduce voltage drop, a larger size conductor or a shorter cable run may be required. To elaborate on supporting and securing metal-clad cable, Article 330.30 requires that metal-clad cable be supported and secured at intervals not exceeding 6 feet and within 12 inches of boxes, cabinets, and fittings. The supports must be designed and installed so as not to damage the cable. Cable ties, straps, or clamps specifically listed for use with metal-clad cable should be used. The supports must be securely fastened to the building structure. When running metal-clad cable horizontally, it must be supported to prevent sagging. When running metal-clad cable vertically, it must be supported to prevent strain on the terminations. If the metal-clad cable is installed in a suspended ceiling, it must be supported independently of the ceiling support wires. To expand on environmental considerations, Article 300.6 requires that conductors and equipment be protected from corrosion and deterioration. If the storage building has a damp or corrosive environment, metal-clad cable with a moisture-resistant or corrosion-resistant jacket should be selected. Metal-clad cable with a polyvinyl chloride jacket is commonly used in corrosive environments. The connectors and fittings used with metal-clad cable must also be suitable for the environment. If the storage building has a high humidity level, condensation can form inside the metal-clad cable. This can lead to corrosion and electrical faults. To prevent condensation, the metal-clad cable should be installed in a way that allows for drainage. This can be achieved by sloping the cable slightly and providing weep holes at low points. Elaborating on termination requirements, the metal-clad cable must be terminated correctly at the junction box and the fixtures. Use connectors listed for metal-clad cable. These connectors typically have a clamping mechanism that secures the cable and provides a tight seal. The armor of the metal-clad cable must be properly bonded to the connector. This provides a path for fault current to flow back to the source. The conductors must be properly terminated at the terminals of the junction box and the fixtures. Ensure that the conductors are securely fastened and that there are no loose strands. The insulation on the conductors must not be damaged during termination. If the conductors are spliced in the junction box, use approved splicing methods. Wire nuts or other splicing connectors must be listed for the size and type of conductors being spliced. To elaborate on grounding requirements, Article 250 provides comprehensive requirements for grounding and bonding. The metal-clad cable must have an equipment grounding conductor that is properly connected to the metal enclosures of the junction box and the fixtures. The equipment grounding conductor must be sized according to Table 250.122. For a 20 amp circuit, the equipment grounding conductor must be at least 12 American wire gauge copper. The equipment grounding conductor must be connected to the grounding electrode system of the building. This provides a path for fault current to flow back to the source and trip the overcurrent protection device. The metal enclosures of the junction box and the fixtures must be bonded together. This ensures that all metal parts are at the same electrical potential. Bonding can be achieved by using bonding jumpers or by using listed connectors that provide a bonding connection. Expanding on overcurrent protection, Article 240 addresses overcurrent protection. The circuit breaker or fuses protecting the metal-clad cable must be sized according to the ampacity of the conductors. The overcurrent protection device must be rated to interrupt the available fault current at the point of installation. The overcurrent protection device must be readily accessible and clearly labeled. If the metal-clad cable supplies a continuous load, the overcurrent protection device must be rated at not less than 125% of the continuous load. Elaborating on junction box suitability, the existing junction box must be suitable for the intended use. The junction box must be large enough to accommodate the conductors and connections without overcrowding. Article 314.16 provides requirements for the minimum size of junction boxes. A junction box must be rated for the environmental conditions of the storage building. If the storage building is damp or wet, the junction box must be rated for wet locations. The junction box must be securely mounted to the building's structure. The cover of the junction box must be securely fastened to the box. Elaborating on compliance with the National Electrical Code, the installation must comply with all other applicable requirements of the National Electrical Code. This includes requirements for working space around electrical equipment, identification of conductors, and protection of conductors from physical damage. Article 110.26 provides requirements for working space around electrical equipment. Sufficient working space must be provided to allow for safe access and maintenance of the equipment. Article 310.11 provides requirements for identification of conductors. Conductors must be identified by color coding or other means. Article 300.4 provides requirements for protection of conductors from physical damage. Conductors must be protected from abrasion, impact, and other forms of physical damage. Elaborating on metal halide lighting fixtures, Article 410 addresses lighting fixtures. Ensure that the fixtures are properly installed, grounded, and ventilated. The ballast for the metal halide fixtures must be suitable for the voltage and frequency of the electrical system. The fixtures must be mounted in a way that prevents them from overheating. The fixtures must be protected from physical damage. The lenses of the fixtures must be kept clean to maintain light output. In summary, when using metal-clad cable for powering 1000-watt metal halide fixtures, you must consider ampacity, voltage drop, support, environmental conditions, termination, grounding, overcurrent protection, junction box suitability, compliance with the National Electrical Code, and the requirements for metal halide lighting fixtures. By following these guidelines, you can ensure a safe and code-compliant installation.